Good evening. Our last topic was internal resistance of vessel, right? We have discussed about EMF. We have discussed about EMF and TPD. What was TPD? Terminal potential difference. TPD is terminal potential difference. We have discussed about the terminal potential difference and the EMF. We understood what was that EMF and terminal potential difference. And did we see the equation for internal resistance? Equation for internal resistance. Did we write the equation for internal resistance? No, that's not equation for internal resistance. That's equation for TPD, voltage, terminal potential difference. That's terminal voltage. V is terminal voltage, right? It's terminal voltage. So the equation is for terminal voltage. Okay? The equation is for terminal voltage. Oh, Natasha is alright. Let's see. What was the equation for terminal voltage? Yeah. Our equation for terminal voltage, I will write it. Equation for terminal voltage is this. Our equation for terminal voltage is this. V is equal to E minus IR. This is our equation for terminal voltage, right? V is terminal potential difference or terminal voltage. E is what? E is EMF. E is EMF of that cell. We know what is the difference between this terminal potential difference and EMF, right? And this is what I into R. I is the current through that circuit. R is internal resistance. Yeah, R is internal resistance. The cell can be represented like this. This is a resistor. R is its resistance, and this is the symbol for cell, EMF. This is the symbol for EMF, and it is internal resistance. So this is EMF and this is internal resistance. Now this is our circuit. This is our circuit, right? And this is the representation of a cell. This is the representation of a cell, right? This is the representation of a cell. Now this is the cell. This is the cell. Okay, and current will be passing through this circuit like this. Please come. Current will be passing through this circuit like this. This is positive terminal and this is negative terminal. Okay, and current is passing through this circuit like this. And current is passing through this external resistance. It is passing through this external resistance, and this is internal resistance of the cell. Internal resistance of the cell. Okay. And what is this equation for voltage or terminal voltage? That's E minus IR. Yeah. We have seen that voltage equation from equation of current. Equation of current, you have that small derivation with you, right? And we have to find the equation for internal resistance. What will be the equation for internal resistance from this equation? From this equation, you can bring this IR to the other side, right? This minus IR to the other side, that will be positive IR. So that will be IR is equal to E, V to the other side, E minus V, E minus V. It is E minus V. Okay? And you need this equation for R. What will be equation for R? What will be equation for R? You have E minus V here. Bring this I to the other side. Then by I. E minus V by I. This is the equation for internal resistance. Right? This is the equation for internal resistance. Now you have an equation for internal resistance. R is equal to E minus V by I. Okay? And what is Ohm's law? By Ohm's law. By Ohm's law, we have V is equal to IR. By Ohm's law, we have V is equal to I. Right? Then what is I? What is I? I is V by R. I is what? V by R. I is V by R. So this equation will become E minus V by I. I is what? I is V by R. Now this R will be coming to the top. Take the reciprocal and multiply. R will be coming to the top. So R, small r will be E minus V by into R by, right? Into R by V by R will be R by V. So into R by V. Okay, and give this V to E. So E by V minus V by V into R. Okay, and what is this? What is this? Internal resistance R is equal to E by V minus 1 into R. Next equation. E by V minus 1 into R. This is next equation. So you have two equations for internal resistance now. You have two equations for internal resistance. The first equation is R is equal to E minus V by I. Right? E minus V by I. This equation can be used if you have E, V, and I. Right? If you don't have that, if you have only E, V, and R, then the equation will be like this. R is equal to E by V minus 1 into R. Okay? These are the two equations for internal resistance. Can you write this? Then write equation for internal resistance. 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 Write the equations that you can see on board. How to complete this chapter today. This was a medium sized chapter, but some topics is related. So we will be able to complete this chapter by today. Arfat, Gobiga, Jumana, Natasha, all of you are online. Is this topic okay? Is it better? First time or this? Second time, sir. This one. Can you see to the board? Arfat, Gobiga, Jumana, Natasha. Can you guys see the board clearly? Yeah. Okay. Then I have to show you one case. That's for maximum current. For maximum current. What will be the maximum current that can be drawn from a cell? What will be the maximum current that can be drawn from a cell? So that's our next point. Maximum current. Maximum current that can be drawn from a cell. Right? If there is no external resistance, if there is no external resistance, that is R is equal to 0, then that time you can draw maximum current from a cell, right? You can draw maximum current from a cell. What is the equation for current? Equation for current is EMF divided by total resistance, effective resistance, right? What is EMF? That's E. E divided by total resistance is what? R plus R is total resistance. R plus R is total resistance. Now R is 0. If R is 0, you have maximum current. So maximum current will be E divided by R. EMF divided by internal resistance will be the maximum current. This is the equation for maximum current. You can write this. It's so simple, right? Equation for maximum current. Just write it. Maximum current. When external resistance is 0, Equation of I is EMF divided by resistance. There is only one resistance now in the circuit. What is that? That's only internal resistance. So the equation will be E by R. Yeah.
So the right hand side you are equal to E by V minus 1 or minus I. Minus 1.
This one.
Yeah, 1.
Is there any problem?
No,
This V by V.
I'll stop.
V by V will be 1. Did you get it? Huh? This is the equation. Now V is applicable to both E and V. So E by V minus V by V. This V by V is 1. So E by V minus 1 in R. That's another equation for internal resistance. Is that okay? Okay. Now we have to write the note for factors affecting internal resistance. What are the factors affecting internal resistance? Okay. I'm moving to the next page, and our topic is what? Factors affecting. Yes, factors affecting internal resistance. Internal resistance. We have discussed about that factors, right? What are the factors that is affecting internal resistance? Tell me. Temperature. Yes.
Length of conductor. Length.
Not length, that's the distance between electrons. Now we are talking about cell. We are not talking about a conductor, we are talking about a cell.
But I can is length.
Yeah, distance between the electrons will be one factor that is affecting internal resistance. And
Resistivity.
resistivity is also there. That you can summarize that into like this: nature of electrolyte, then temperature, nature of electrolyte, distance between electrons, area of cross section of electrons, concentration of electrolyte, all this. Okay, right. I'll give you the note. Right. First one: nature of electrodes and electrolytes. First point: nature of electrodes and electrolytes. Nature of electrodes and electrolytes. Nature of electrodes and electrolytes. What's the second one? Write the second one. Concentration of electrolytes. Concentration of electrolytes. Concentration of electrolytes. Concentration of electrolytes. Then distance between electrodes. Distance between electrodes. If the concentration is increasing, internal resistance will be increasing. Okay. Distance between the electrodes. Distance between the electrodes. And it is directly proportional. If distance is increasing, distance between the electrodes is increasing, internal resistance will be increasing. So distance between the electrodes is affecting it. Fourth one: area of cross section of electrodes. Area of cross section of electrodes. That's fourth one. Area of cross section of electrodes. Area of cross section of electrodes. And it is inversely proportional. If area of cross section of electrodes is increasing, internal resistance will be decreasing. So it will be inversely proportional. Area of cross section of electrodes are inversely proportional to A. And temperature of electrolyte. Temperature of electrolyte. Temperature of electrolyte.
25 points.
Yeah. Temperature of electrolyte.
So both temperature of electrodes and electrolytes we wrote.
Did we write it?
No, we should write both. Electrodes.
Temperature of electrolyte and electrodes. You can write it. It is affecting if it affecting more with the case of electrolytes. Because in electrolyte, there will be ions in it. Ions in it. The movement of ions is depending upon temperature. Okay. And now we have to discuss combination of cells. Combination of cells. We are going to discuss about combination of cells. Combination of cells. There is two types of combination. One is series combination, the other is parallel combination. But we are not talking about resistors here. We are talking about cell here. We are connecting the cell in series and we are connecting the cell in parallel. And let's see what is the equivalent resistance, what is the equivalent resistance and what is the equivalent EMF. That's what we are going to see. Okay. First, we are connecting cells in series. We are connecting cells in series. So that is series combination. Series combination. You can write with me. Series combination. Okay. Let's see what is series combination. Series combination. Series combination means this. This is EMF of a cell, right? This is EMF. Yes, this. EMF of a cell, and it is connected. This is represented like this. A cell can be represented like this, an EMF and an internal resistance. So this is the first cell. So EMF is E1, internal resistance is R1. Okay. Then the second one. This is the second cell. EMF of second cell is E2, and the resistance of internal resistance of second cell is R2. Is it okay now? Now it is powering a load resistor. It is connected to a load resistor. That load resistor is capital R. Capital R is a load resistor. Load resistor. We can measure voltage from there. We can measure voltage from there. Now, this is what? This is one cell. This is one cell. And what is this? This is our second cell. So we have two cells and we have connected two cells in series. We have connected two cells in series. So there is one cell after the other. One cell after the other. Positive of one cell is connected to the negative of the other cell. That is series. Positive of one cell is connected to the negative of the next cell. That is series connection. One cell is connected after the other. One cell after the other. One cell after the other. That's this connection. One cell is connected after the other. That is positive to negative. And this positive to the other negative. That's series connection. When positive is connected to negative, that is series connection. You got it? And I am naming some points here for our use. I am naming a point here, that is A, and this is B, and this is C. I have named some points here, A, B, C. A, B, C. Okay. What will be equation for voltage? What is the equation for voltage? We know the equation for voltage, right? What is the equation for voltage? What is the equation for voltage? If we are considering internal resistance of a cell, what is the equation for voltage? We just wrote it. We just discussed it. What is the equation for voltage? V is equal to E minus IR is the equation for voltage, right? Okay. And if the cell is connected like this, if two cells are connected like this, you can combine the EMF and combine the internal resistance from this figure. So it will be like this: one EMF and one internal resistance. This could be like this: one EMF and one internal resistance. That one EMF will be equivalent EMF. Equivalent, and that one resistance will be equivalent resistance. Equivalent internal resistance. One EMF will be equivalent EMF, and that one internal resistance will be equivalent internal resistance. When we are combining this is what happening. This will be happening. There will be a combined EMF. There will be a combined resistance. We have to see this combined EMF and combined resistance. So that I am using this equation, V is equal to E minus IR. That is the equation containing equation of internal resistance. That is the equation containing internal resistance. Right? Otherwise, the equation is simply like this. V is equal to IR. V is equal to IR. Now this equation contains internal resistance. So V is equal to E minus IR. Okay. And what will be that? VAB will be here, right? VAB. What is VAB? VAB. Look at it. There is a point A, there is a point B. So there will be a voltage. That voltage will be VAB. That potential difference will be VAB. What will be the equation for that potential difference? Yes, VAB is equal to E minus. That is VA minus VB. But we have one equation, E minus IR. What is that?
E1
That's E1. So E1 minus.
I
Yes, there will be only one current in this circuit. There will be only one current in this circuit. That one current will be passing from positive to negative. That one current will be from positive to negative. That one current will be from positive to negative because there is no branch. There is no branch here, so the current will be from positive to negative. Okay, that means there is only one current. So E1 minus I into R1. This is VAB. This is VAB. Okay. And what is VBC? VBC is what? And what is this VAB? VAB should be V or V1. Is it equal or opposite? Equal or is there any two voltages or one voltage? Only one voltage or two voltages. VAB and VBC will be equal or they will be different. Tell me. Are they going to be equal voltages or they will be different voltages?
Depends on the rest.
Because of no, this is R1 and this is R2. They are different. E1 and E2 are also different. So the voltage here and here will be different. VAB and VBC will not be equal. They will not be equal. They will be different. So that's VAB and VBC. What is VBC? Yeah, VBC is what? E2 minus IR2. Now you have VAB and VBC. What will be VAC? What will be the value of VAC?
Both are.
Yeah. What is VAC? VAC is the total potential from this point to this point. Yeah. There is a potential here. There is another potential here. So you can add them to get VAC. What is that? VAC. VAC will be just add these two potentials VAB plus VBC. You will get VAC. You will get VAC. What will be that? VAC is what? VAC is the effective voltage here. A is this point, right? A is this point and C is this point. A is this point and C is this point. That means that's voltage. That's terminal voltage. That's terminal voltage. So terminal voltage will be VAB. What is VAB? What is VAB? That's E1 minus IR1 plus E2 minus IR2. E2 minus IR2. Okay. Now I can combine this. V is equal to, I can combine this E1 plus E2. I am writing it together. E1 plus E2. I am writing it together. E1 plus E2. E1 plus E2, right? E1 plus E2 minus I into R1 plus R2. R1 plus R2 minus I into R1 plus R2. E1 plus E2 minus I into R1 plus R2. This is like this. What will be the equation of this case? If we are considering this EMF as equivalent EMF and internal resistance as equivalent internal resistance, what will be the equation here? The equation here will be V is equal to E equivalent. There will be current, right? Like this. E equivalent minus I into R equivalent. E equivalent minus I into R equivalent will be the equation. This is like this. Now it is looking like this. That means E1 plus E2, E1 plus E2 minus I into R1 plus R2. This is actually the same equation. This is actually the same equation. That means you can write E equivalent from this. E equivalent. What is E equivalent? What is E equivalent? E equivalent is E1 plus E2. E equivalent is E1 plus E2. E equivalent is E1 plus E2. And what is R equivalent? R equivalent. R equivalent is just R1 plus R2. If you have connected two cells, the equivalent EMF will be E1 plus E2. The equivalent resistance will be R1 plus R2. If you have connected three cells, E equivalent will be E1 plus E2 plus E3. R equivalent will be R1 plus R2 plus R3. Simple cases. So this is the equation for equivalent resistance. So equivalent EMF and equivalent resistance. Equations for equivalent EMF and equivalent resistance, internal resistance. How is this? Simple case. Write it down. Complete. Okay. Put that away. Okay. Let's see.
So, sir, calling this. Your targets there. Even the website, basically, you only get one chat message. Chat on person. And then this day, very big scene about it. Apparently, he was holding the place and showing this guy was there. There was slapping. And that made even Cameron come out and show the things. And said he was very he came back to the
Okay, like
check the ceiling.
after this, look at it. If there is n number of cells, n number of equivalent, did you complete? Right. If there is n number of cells, what will be equivalent EMF and equivalent internal resistance? Equivalent EMF is just E1 plus E2 plus E3, right?
Yeah.
And if you have if you have n number of similar cells, EMF will be E. EMF of one can be taken as E. The other will be same to that. So the other EMF will be also E. The third EMF will be E. So if you are adding it, that will be E plus E plus E plus E up to N. That will be N times E. Like that. Resistance also N times R. Okay. If there are N number of cells, then EMF will be N times E and R will be N times R. You will see that next.
So we can just take E common outside.
In this equation or the other equation.
No, in that.
Yeah.
We take N.
We have to find the equation of current for that. Okay. Let's see what is that. Huh? If there is n number of cells having EMF is equal to E and internal resistance equal to R. what will be the figure? Figure will be like this, right? It will be going all like this. This is E, R, E, R, E, R. It is going all like this. Okay. So what will be equivalent EMF? Equivalent EMF E plus E plus E plus E plus E plus up to N. That is N times E. Right? N times E. Equivalent EMF will be N times E. Like that. What will be equivalent resistance? R plus R plus R plus R. That will be N times R. N times R. That's equivalent resistance. Okay. Then what will be the equation of current? Equation of current. What is the equation of current? I is equal to EMF by resistance, right? EMF by resistance. That is the current drawn from the system. That is the current drawn from the system. That's EMF by resistance or equivalent EMF by equivalent resistance. What is equivalent EMF? N times E. What is equivalent internal resistance? N times R. Okay. If there is external resistance also, you have to add that. If there is an external resistance also, you have to add that to. That means equivalent EMF will be N times E. Equivalent EMF will be N times E divided by N times R. But if you are considering in external resistance also, then that will be R plus N times R. You are considering external resistance also. This is external resistance. It is connected to the system. Right? It is connected to the system like this. So the equation for current will be NE divided by R plus NR. This is the equation for current. Is it okay?
The swinging at first.
It is not swinging.
No, sir.
Okay. Is it okay now? Okay. Take this note. Take this note. If there is n number of cells having EMF is equal to E, internal resistance is equal to R. Then the case will be like this. Okay. After this, we have to see the combination of cells in parallel. How to see the combination of cells in parallel. Is the topics okay for you, Arafat, Gobika, Jumana, Natasha? Can you guys understand this? Okay. Okay, I'm going to the next one. Next topic. What is that? Combination of cells in parallel. Or parallel combination simply. Parallel combination of cells. Parallel combination of cells. Parallel combination of cells. Parallel combination of cells. Okay? What is parallel combination of cells? I am just considering two cells. I am considering two cells. One cell can be represented like this. This is one cell, right? This is EM of E1 and internal resistance R1. It is connected to another cell like this. That is positive to positive, negative to negative. Positive to positive, negative to negative. That's parallel combination. That's parallel connection. This is positive, this is positive. So positive to positive, negative to negative. That's parallel connection. Now this is a parallel connection.
What's the
Yeah. This is parallel connection, and I am taking out a wire like this and I am connecting that to a load resistor. This is our circuit now. This is our circuit now. And I am calling this point as A and this point as B. Okay? And VAB is the voltage that is getting on this cell. Okay? From this cell. And what is this cell? The second cell that has an EM of E2 and R2. E2 and R2. Are they equal or different? Are they equal or different? No, they will be equal. Because voltage is experienced on terminals. Two terminals. Voltage is experienced on between two terminals. It is experienced between two terminals. How many terminals are there? How many terminals are there? Only two terminals are there. Only one pair of terminals are there. That is, this first cell is connected to point A and point B. Second cell is also connected to point A and point B. That means there is only one voltage. This combination will give out only one voltage. Is that okay?
So the series will give. So then how will series come? How is the series combination?
Series combination is like this.
Like
So
there
it's pretty.
Positive to negative.
was three of
Which one? Where is the
terminals.
terminals? Yeah, one. This is between voltage between A and B. First voltage. Voltage between B and C. Second voltage. Now we are considering that as voltage between A and C. Now that's it. Like that. Okay. So look at it. We have two cells which is connected in parallel. We are connecting these two cells in parallel. It's parallel connection. The cells are connected in parallel means positive of a cell is connected to positive of the next cell. Okay, in parallel combination, positive terminal is connected to one cell. Positive terminal of one cell is connected to positive of the next or positive of the second cell. Positive of the second cell. That's parallel combination, right? Now we have a combination. What will be the equation? You can write equation of VAB. What will be the equation of VAB? Equation of VAB will be what? Yeah.
One by
We have this equation. V is equal to E minus IR is our equation. No. I'm just asking for VAB equation, voltage equation. What is your voltage equation? E1 minus. There is the problem. That's the problem. The current that is coming out of here will be I1, right? The current that is given out of this cell, getting out of this cell will be I2. Both of these current will be combining to form this I. Right? This cell will be giving out this I1. The second cell will be giving out I2. Both of them will be combining to form this I. Right? That means there is I1. I1 is the current of this cell. So E1 minus I1 into R. Okay, that's VAB. That's VAB. From this, I can find what is I1. I can find what is I1. I need that. So I am going to find what is I1. I can bring this minus I1 R1 to the other side. That will be plus I1 R1. I1 R1. I can take this voltage as V. This voltage can be taken as V because there is only one voltage. VAB can be taken as V. So V is equal to E1 minus I1 R1. Now I can find what is I1 from this. What is the value of I1 from this? What is the value of I1? I am taking this minus I1 R1 to the other side of the equation. That will be plus I1 R1 is equal to what is the that's E1. So E1 minus V. That's E1 minus V. Now I am going to find I1. What is I1? I1 is equal to E1 minus V by R1. That's I1. That is I1. Okay. Now the second equation. This is the first equation. This is the first equation. Now I can write the second equation. What is the second equation? What is the second equation? The voltage is same. So VAB is also equal to VAB. What is the next equation for VAB? The next equation for VAB E2 minus I2 R2. What is VAB? That's V. V is equal to E2 minus I2 R2. Now I want to find what is I2. I want to find I2. Bring this minus I2 R2 to the other side. That will be plus I2 R2. Plus I2 R2 is equal to, here you have E2. Bring this V to the other side. E2 minus V. E2 minus V. What is I2? What is I2? E2 minus V divided by R2. That's I2. Now we have the relation between I1 and I2. What is the relation between I1 and I2? I1 and I2 are combining together to form I. I1 and I2 are combining together to form I. I1 and I2 are joining together. They are adding them. They are adding them. That means I can be written as I is equal to I1 plus I2. That will be the current. That will be the current. I will be I1 plus I2. That means you can write I1 and I2 for equation of I1 and I2 for I1 and I2 here. So I1 is what? I1 is E1 minus V divided by R1. Okay. Plus, what is this? What is this? E2. I2 is E2 minus V by R2. Okay. And I am splitting it. If I am splitting it, that will be E1 by R1 minus V by R1. Right? So E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. Is that okay? I'm splitting it. I can write like this, right? So I have split it. And what will be the next equation? I'm combining the terms of E1 and E2 together and combining the terms of V to the other side. Then the equation will be like this. The equation will be like this. I have equation for I. I is equal to E1 by R1. E1 by R1 plus E2 by R2. I am writing them together. E2 by R2. Is that okay? And just look at it. Minus V is a common term. Minus V by R1 minus V by R2. So minus V is a common term. That means you can take out this minus V as a common term. So minus V. If you are taken out minus V, what will be inside of the bracket? 1 by R1 here. Inside of the bracket, you have 1 by R1 plus because you have taken out minus V. You have taken out minus V. So 1 by R1 plus 1 by R2 will be inside the bracket. Okay. Okay, then I am bringing this minus V to the outside because the equation I need should be like this. The equation I am needing should be like this. V is equal to E equivalent minus I into R equivalent. The equation I need should be like this. For that, I need this V to the other side. Okay, so I am bringing this V, that will be plus. If that is minus, so I am taking to the other side, that will be plus. V into 1 by R1, 1 by R1 plus 1 by R2 is equal to what is here? There is a I, right? There is I here. There is I here. So I am bringing this I to the other side. This side you have E1 by R1 plus E2 by R2. If I am bringing this I to the other side, I have minus I like this. Now it is almost looking like this equation. Almost V. There is into a term. V into a term. So I have to bring this term to the other side. Then I will get this equation. Right? And cross multiplying it, what will be that? Cross multiplying it, V into, this is R2 plus R1 or R1 plus R2. R1 plus R2 divided by R1 R2. R1 plus R2 divided by R1 R2. Okay. And I am cross multiplying this also. What will be that? E1 into R2 plus E2 into R1 divided by R1 R2. Is that okay? I am cross multiplying this. E1 into R2 plus E2 into R1 divided by R1 into R2. Is that okay? Okay, minus I. Minus I. Now I am letting this V stay here and bring the other side, other term to the next term to the other side. What will happen then? V is equal to, you have E1 R2 plus E2 R1 here divided by R1 R2 on the numerator. If you are bringing this term to the other side, what will happen to it? The reciprocal will be there on the other side. This R1 R2 will be coming to the numerator. That means R1 R2 will be on numerator of this term divided by, what is this? R1 plus R2 will be on the denominator of this term plus minus I into this term is coming to the other side, right? This term is applicable to this term and the term of I also. Okay, so minus I into R1 R2 will be coming to the top. R1 R2 will be coming to the top divided by R1 plus R2. R1 plus R2. Okay, so what will happen now? Yes, R1 R2 will be cancelled from the equation. R1 R2 will be cancelled. Yeah, R1 R2 is here. Here you have R1 R2. Here you have R1 R2. You are bringing this R1 R2 to the other side. It will be into R1 R2 here, into R1 R2 here. So this R1 R2 is cancelled from this R1 R2 from this equation.
Minus I.
Minus I into this term. This whole term, you are bringing that whole term to the other side of the equation, right? Then this whole term is applicable to both this term and this term because there is a minus between them. If there is a multiplication sign, then you don't have to write it 2 times. Then there will be only one term. There is 2 terms actually. So you have to multiply this term with this term, also this term. That's what happens. Jovita, can you close that door? So, what will be the next one? V is equal to, what's on numerator? E1 R2 plus E2 R1 divided by R1 plus R2. Okay? Minus I into R1 R2 divided by R1 plus R2. This equation is looking like this equation. This equation looks like that equation. V is equal to E equivalent minus I into R equivalent. That means you have your E equivalent now. What is your E equivalent? This is your E equivalent now. That's your E equivalent now. And what is your R equivalent? This is your R equivalent now. You have the equations for both E equivalent and R equivalent now. What is equation for E equivalent? Equation for E equivalent is what? Equation for E equivalent. E equivalent. What is equation for E equivalent? That's E1 R2 plus E2 R1 divided by R1 plus R2. That's E equivalent. Okay, that's E equivalent. Now you have equation for E equivalent. That's the equation for E equivalent. What is R equivalent? R equivalent is what? R equivalent is R1 R2 by R1 plus R2. R1 R2 divided by R1 plus R2. What is this actually? R1 R2 by R1 plus R2 is what is actually? What is that equation? Are you familiar with that equation? R1 R2 by R1 plus R2. What is that equation? In real, what is that equation? You know that. You know that. You are familiar with this equation. Yeah. Equivalent resistance. That's the equation for equivalent resistance itself. That's the equation for equivalent resistance itself. Like this, 1 by R is equal to 1 by R1 plus 1 by R2. Yeah. And R will be R1 R2 divided by R1 plus R2. That's the same equation. So if the cells are connected in parallel, resistance, internal resistance will be equivalent resistance. It will be resistance in parallel, but cell will be like this. Equivalent EMF will be like this. So cell equivalent EMF will be like this. E1 R2 plus E2 R1 divided by R1 plus R2 will be the equation for equivalent EMF. That will be the equation for equivalent EMF. You can write this now. You can write it now.
From 10th grade, we found like for parallel circuits,
Yeah.
voltage will be 1 by V.
Yes, sir.
1 by V. Yeah.
1 by V. No.
Total resistance. So total
Resistance will be 1 by R.
total voltage.
Total voltage is only V. You cannot have two voltages because voltage is experienced on two terminals of the cell or two terminals of an element. If you have taken an element like this, you have an element here and you have the next element like this. This was the figure you have studied in 10. Okay. Now you have this R1 here, R2 here, right? So only one voltage here. Only one voltage. The voltage will be applicable to both this R1 and R2. But the current will be splitting. When current is I and current will split at this junction. Current will split at this junction and current will flow through this. That will be I1 and the next current will be I2. Okay. The figure was that. Voltage is same.
So can we have
Huh?
yeah.
If you have, we can break. We can go to break at the 5:30. That's 5:24. Is the topic okay for Arfat, Gobiga, Jumana, Natasha, Neha? Neha?
What is your regards of empty pages?
You came a little bit late. Neha? Did you?